Okay, good afternoon. This is Professor Khan, and in this video I would like to share with you, I would like to solve with you the last homework problem we did for a combination circuit, and hopefully this will help you understand how it's done. So in the homework we had this circuit over here where we have voltage and two resistances. And ammeter. So the ammeter is connected in series with the circuit and should measure the amperage coming out of the circuit. The voltage is 110 volts, and the resistance is here. This is 20 ohm, and this is R2 is actually R2 is 10 ohm, 20 ohm, and R3 is 15 ohm. R4 is 30 ohm. So let me just check that, make sure that this is clear. Yeah, it is clear. Okay, so what is the system total resistance? That's the first thing you have to look at and try to consider. So I'm gonna get my calculator here. So the first thing is to know, are these resistances in series or in parallel with each other? They are in parallel with each other. So I'm going to resolve this circuit first, and the RT here will equal 10 plus 20, and I will do the flip, which is 1 over RT equal 1 over 10 plus 1 over 20. That's equal 1 over RT. If D divide, so I divide 1 over 10, that's 0.1. 1 over 20 is 0.05. Then add, I'll add them together, 1 over RT. That's equal 0.15. Then I will divide again, flip again, flip. So this RT will equal 1 over 0.15, and that equals I got here 6.66 ohm. So this is going to be the total resistance for this circuit over here. What about this circuit over here? I'll do the same thing because those two are in parallel. But this circuit and this circuit are in series with each other. So I'm going to resolve the parallel circuit first, then I'll move on. So in here, that will be as well. So this here, this total here is 6.66 ohm. In here, our T will equal 15 plus 30. So I will flip 1 over RT, 1 over 15 plus 1 over 30. Then divide 1 over RT equal 1 over 15. That's 0.066 plus 1 over 30. That's 0.033. Then add, so 1 over RT will equal plus 0.0999. Then finally flip again, and that will be RT equal 1 over 0.099. Don't forget the 0 here. So that will give me 10 ohms. So this in here as total RT equal 10 ohm. So the question is asking what is the circuit total resistance, which means like the entire circuit, which is all the resistances in it. So these are in parallel, but those two are in series with each other. So our total for the circuit will equal 6.66 plus 10 ohm. So in that case, they are in series, so you just add them together, and that will be 16.66 ohm. So we got that for the resistance. So that's clear. And I will move on to the side here to go and do the other side. So the other question is, what is the system ammeter reading? So this is amperage. So amperage will equal voltage over resistance from Ohm's law, correct? The voltage is 110, the resistance which is the total circuit resistance, will be 16.66 ohm. This is volts. So that will give me 110 over 16.66. I got 6.6 amps. 6.6 amps. Good. So that's the circuit total resistance. What is the power consumption? We know power equal voltage times amperage. Correct? Voltage is 110 volts times amperage, which is 6.6 amps. So that will give me times 110. I got 726 watts. Okay? So that's my power consumption per hour. It's a watt. So how much would it cost you to run the system continuously for a week if the power cost 15 cents? So the cost will be 15 cents a kilowatt hour. So we need kilowatts, right? So I'm going to convert this to kilowatt. So this is 726 watts equal 726 over 1,000 to give you kilowatt, right? So that's going to be 0.726 kilowatt. So I have 0.726 kilowatt times the cost, which is 15 cents, not dollars, cent. That 0.15 is 15 cents in a dollar per kilowatt, times a week continuously, which is 24 hours a day, times 7 days a week. And if I multiply all these together, that should give you the cost for an entire week. So over 1,000, 0.726 times 0.15 times 24 times 7, and here I got around $18. $18.26 for a week. So I hope this makes sense, and the most important part is to recognize circuits. You might see another circuit like that with 3 maybe, and another 3 resistances in. So this is in parallel, and this is in parallel, but these two circuits are in series with each other. So make sure you don't mess up the addition of resistances for series and parallel. Okay, I hope this makes sense. Showing you over here, this is the entire calculation, so you can rewind and look at it when you need to. All right, thank you.